Okay, lesson 33, converse of the Pythagorean theorem. Now remember, converse means the opposite, right? So we know by now that the Pythagorean theorem is used for right triangles, and it says that a squared plus b squared equals c squared. So if this works out this way, then we know it's a right triangle. Now, if the c squared is bigger, then the triangle is obtuse. If the c squared is smaller, then it's an acute. So far, we've only been working with right triangles that are exact. So it's always equaled. Okay, let's look down here where it says determine whether each triangle is a right triangle. So we're going to say yes or no. We're only going to say yes if it equals. So over here we have 4 squared plus 11 squared equals 12 squared. Okay, this is 16 plus 121 equals 144. 16 plus 121 is 137. That does not equal 144. So we're going to say no. It is not a right triangle. Okay, you pause the video and try this one. All right, so we have 5 squared plus 12 squared equals 13 squared. This is 25, this is 144, and this is 169. Add these together, you get 169 equals 169. Yes, this is a right triangle. Okay, down here, they want us to determine whether this triangle is obtuse, acute, or right. So we are going to, first of all, examine the sides. Okay, notice the 9 is the biggest, which means it has to be the hypotenuse. Therefore, we will write 4 squared plus 8 squared equals 9 squared, because C has to be the longest side. 16 plus 64 equals 81. 16 plus 64 is 80. And 9 squared is 81. That means that the C, right? The C is bigger. Therefore, it is obtuse. When the C is bigger, it's obtuse. Okay, you try this one. Determine whether this triangle is obtuse, acute, or right. So remember, the largest number is the longest side, which is the C. So pause the video and give this one a shot. Okay, so here we have 5 squared plus 6 squared equals 7 squared. This is 25 plus 36 equals 49. Add those together, we get 61, which is greater. So the C is smaller than, which means this is an acute. Pause the video and try these. Determine whether they're acute, obtuse, or right. Okay, for this one, you should have gotten a right. Over here, you should have gotten acute. This one is obtuse. And the last one is also acute. How'd you do? If you missed any of these, go back and check your work. It was probably a calculating error, or you forgot which signs meant what. But it'll get better with practice. Okay, moving on to lesson 34, which is properties of parallelograms. So let me explain this table real quick. Properties of parallelograms. if it's a parallelogram, then its opposite sides are congruent. Opposite angles are congruent. So you see how this angle is congruent with this angle, and this angle is congruent with this angle. Another thing to remember is that the consecutive angles are supplementary. So angle S is supplementary to angle T, which means these add up to 180. These are also consecutive, so they add up to 180. So these two angles are 180, and these two angles are 180. These two angles are so whatever angles are right next to each other are 180. Opposite sides are congruent. Notice how this side is congruent with this side, and this side is congruent with this side. And then lastly, the diagonals bisect each other. So see these diagonals? When it says they bisect each other, this one's congruent to this piece, and this piece is congruent to this piece. Okay, let's use these properties to help us answer these questions down here. So it says find the value of each variable. So remember, with these parallelograms, opposite sides are congruent. So we're going to set these two equal to each other. Also, we know that diagonals bisect each other, which means that this piece is congruent to this piece. So we're going to set these two equal to each other. All right. So we have 3x plus 10 is equal to 7x minus 8. We bring the 3x over to get 4x on the right. We get 18 on the left when we add the 8. We divide by 4 on both sides. We reduce, and x becomes 9 halves. Or if you wanted to write it in decimal form, you could have written 4.5. Okay, now let's set these equal to each other. So we have 1/2 y plus 10 is equal to 2y minus 2. So first, we're going to subtract half of a y over here. So this leaves with 1.5y. Add 2 over here, and that becomes 12. When I divide by 1.5 on both sides, I get y is equal to 8. All right, now moving on over here, we know that opposite angles are congruent. So we're going to say that 28x plus 5 is equal to 145. If we subtract 5, we get 140. And if we divide by 28, we get x equal to 5. Another thing about parallelograms is that their opposite sides are congruent. So once again, -2 plus 8x is equal to 22. We add 2 to both sides, which gives us 24. We divide by 8, which gives us x equals 3. Now be careful with this one. They said that consecutive sides are supplementary. So don't get in such a habit of setting all these equal to each other that you just do it robotically. You have to pay attention to what's happening. Those two add up to 180. So we're going to say 120 plus 6x minus 12 is equal to 180 because they're supplementary. So 120 take away 12 is 108. Okay, and then we subtract 108, we get 72. And x is equal to 12. And that is properties of parallelograms. Okay, lesson 35, finding arc lengths and area of sectors. Super simple as long as you have the formulas, so make sure these get put in your formulas chart. For arc length, they're going to give you the measure in degrees, but they want it in units of like centimeters or inches, okay? Because it can be measured in two different ways, degrees or the actual length, which is measured in units. Okay, this is the formula right here. I want you to notice something. This is the circumference formula, 2 pi r. So all you have to remember when finding arc length is use the circumference formula times whatever they give you for this divided by 360. Now for area of a sector, notice how it's the area of a circle formula, pi r squared. And then same exact thing, m divided by 360. So for area of a sector, you're finding the area of this piece of pie. For arc length, you're finding the measure of this right here. It's like a piece of the circumference. Okay, so let's apply these formulas together. Down here it says find the length of arc xy. So that would be right here. So you notice how they give me the radius, so that's going to go right there. They also give me the measurement in degrees, which is going to go right there. So it's basically just a plug and play. We're going to fill in the formula with the information they give us and then just solve. So here we have arc xy is equal to 2 pi 15, I'm just using the formula, 60 over 360, right? I got the 15 from the radius, and I got the 60 from the measurement given of the arc. Now, when I plug this into my calculator carefully, I get 15.7, and we're going to label that centimeters. So let me see if I can show you. So 2 second pi 15 open parentheses 60 divided by 360 close, enter. So 15.7 right there. Okay, now over here they want us again to find the length of the arc. Here's the 75 degrees of the arc, and here's the radius of 4 feet. So once again, we're going to plug into the formula. So L, I'm going to use that for length, equals 2 pi, the radius is 4, open parentheses, 75 divided by 360. We plug that into our calculator very carefully, and we get 5.2 feet. Now, since it's length, like circumference and perimeter, we just label it in its units. We don't put squared. However, now that we're finding area of sector, we're going to be sure to label it with units squared. Okay, remember what I told you. Area uses the pi r squared. So we're going to do pi 12 squared, right? Open parentheses, 95 over 360. When we plug that in, we get 119.4 inches squared. So let's try that over here. We have pi 12 squared parentheses 95 divided by 360, 119.4 inches squared. Okay, why don't you pause the video and try to find the area of this word problem using this as your degrees and this as your radius. So once again, pi r squared 174 over 360. If you punched that in carefully, you should have 256.6 meters squared. Okay, this time they want us to use the formula to find the radius. They give us the area. See what they did there? So they want us to plug in 100 equals pi r squared 246 360. Okay, so we want to flip this so we can get rid of it here and move it to the other side. So we have Okay, so I'm going to plug that in. $146.34. Divide by pi. So divide by pi, 46.58. Equals r squared. We have to remember to take the square root because we don't want r squared, we want r. So I have to go back over here and I have to do second square root, second answer, 6.8. R is 6.8 meters. There's my radius. All right, let me erase that and make some room for this last problem. It's asking us to find the central angle. So remember, central angles are equal to their intercepted arcs. So really they're asking us to find this, and then we'll know this. Okay, and it says find arc RS to the nearest hundredth of a degree, so rounded 2 decimal places, if the length of the arc is 12. So they gave us the length. Remember, length is 2 pi r, right? So we have length, which is 12, they gave that to us, equals 2 pi r, 14. They want us to find the degrees, right? They want us to find the central angle. That's in degrees right here. If I have this, I have this. Okay. So currently it says divide by 360. So the way I can get rid of that is I can multiply both sides by 360. And then that'll get rid of it over here. Now I need to divide both sides by 2 pi 14, and then I'll get x alone. You see that? 2 pi 14. So let me punch that in carefully. I have to use parentheses. Did you hear me? I have to use parentheses. So here we have 360 times 12, close parentheses, divide by, must use parentheses before I put in 2 pi 14. I think that's what it was. Enter. 49.11, because they said hundredths place. So 49.11 degrees. And there you have it. And that is the lesson part. I would like you to pause the video, practice finding area and arc length, and then come back and check your work. Pause the video and give that a try. Okay, for this one, you should have gotten 102.6 square feet. Remember to label your units. This one's 18.8 miles squared. Bottom left is 23 feet. And then bottom right is 62.8 feet. Go back and check your work if you missed any of these. All right, all your homework and everything is on the Google Doc. So I hope y'all are having a great week, and I'm sorry I couldn't be with you in person.